Dividing complex numbers can be a little tricky, and the problem is we have to leave our number in a plus bi form, where a and b are real numbers, right? And I is the imaginary number, the square root of -1. So the issue is that if you divide a real number by a real number, you get a real number, okay? So how do I take something like 2 plus 3i divided by 4 minus 5i, okay, and get that in the form one real number plus another real number times I? That's the challenge. The problem is that I've got an I in the denominator. This is actually a lot like, you may remember, if you had a radical in your denominator. You may remember from way back in some other piece of math, if you had something like this, 3 plus root 4, you actually had to multiply by a conjugate to do what we over here call rationalize. And if you want to, in your free time, you can multiply this out, and you'll see that this actually takes the square root out of the denominator. We are going to multiply here by what is called the complex conjugate of 4 minus 5i. So the complex conjugate of the denominator, which is 4 plus 5i. 4 minus 5i, the conjugate changes the sign in front of the imaginary part, okay? And it's going to change the value if we don't multiply by the conjugate in the numerator too. Since this is just a clever way of writing 1, we're not actually changing the value. Now you get tons of practice multiplying complex numbers, right? So in the numerator, we're going to multiply 2 times 4, then 2 times 5i. Now I'm going to multiply 3i times 4, then times 5i. That I squared, remember, becomes negative. So maybe I'll just do that now. So that's really negative 15. Now my denominator, what happens? I get 4 times 4, 16, 4 times 5i, 20i, negative 5i times 4, negative 20i. This is the whole reason that you have the complex conjugate. Then negative 5i times positive 5i, negative 25i squared. These cancel. They should cancel every time. If they don't cancel, you didn't do the conjugate right here. Then this I squared becomes positive. So what do I get out? I get out, let's see, 8 minus 15, so that's negative 7, plus 22i over 16 plus 25. So I guess that's 41. Then I can write it in the form of a complex number. That's the whole goal. I can write negative 7/41, that's a real number, plus 22/41 I. There's my answer.